Our topic is strength of figures, and in solving for the strength of figures, we will cover geometric conditions, next factor for a triangle, and lastly the tabular difference for 1-second error. Okay, so strength of figures is denoted by R equal to F factor times the summation of delta A squared plus product of delta A and delta B plus delta B squared. Okay, this is the strength of figures. Okay, this is the factor F, and F is equal to D minus C all over D. D is the number of directions observed, not including the fixed or known side of a given figure. Again, D is equal to the number of directions observed. And C is the geometric conditions. A and B are distance angles. Okay, next. In order to solve for the strength of figures, we need to get or determine the geometric conditions, the number of geometric conditions. Okay, and the formula for the geometric conditions is C is equal to n prime minus s prime plus 1 plus n minus 2s plus 3. Again, C is the number of geometric conditions. Next, n prime, number of lines observed in both directions, including fixed or known side of a given figure. S prime, number of occupied stations. And total number of lines in figure, including fixed or known line. And S, total number of stations. Okay, let's have an example. We have example number 1. Assuming that all stations are occupied and all lines are observed in both directions, determine the number of geometric conditions that will be used in the determination of the strength of figure for a single triangle. Okay, so we have here is a triangle. Okay, let's write the formula for geometric conditions. C is equal to n prime minus s prime plus 1 plus n minus 2s plus 3. Okay. So we have a triangle. So n prime, which is the number of lines observed. So in a triangle, we have 3 lines. Next, S prime. S prime is the number of occupied stations or the vertices of a triangle. We have also 3. Next, N, total number of lines in the figure. We have 3. And S, the total number of station. Also the vertices, 3. Okay, so let's put the values. C is equal to 3 minus 3 plus 1 plus 3 minus 6 plus 3. Our geometric condition is 1. We have example number 2. Assuming that all stations are occupied and all lines are observed in both directions, determine the number of geometric conditions that will be used in the determination of the strength of figure of a quadrilateral with an interior station and 1 diagonal. Okay? For this, let's draw a quadrilateral. So these are the stations occupied. And it says here it has an interior station. Okay, somewhere here. And all lines are observed. And 1 diagonal. Okay. Let us determine the number of geometric conditions. So the formula, C is equal to n prime minus s prime plus 1 plus n minus 2s plus 3. Okay. C is equal to n prime is the number of lines observed in both directions. Okay. Let's count the lines observed in both directions. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the lines observed is 9. Next, S prime, which is the number of occupied stations. So station A, station B, station C, D and E is equal to 5 stations. N, total number of lines in the figure, 9. And S, the total number of station is 5. Okay. C is equal to 9 minus 5 plus 1 plus 9 minus 10 plus 3. So, C is equal to 7. Example number 3. Compute the value of the strength of figure factor F for a triangle with interior station and one known line, assuming that all stations are occupied and all lines are observed in both directions. Okay, so we're computing for the value of factor F. So the formula for F is equal to D minus C all over D. Again, D is the number of directions. Right, and C is the geometric conditions. Okay, first we determine the geometric condition, the number of geometric conditions. Okay, C is equal to n prime minus s prime plus 1 plus n minus 2s plus 3. Okay, so let's draw a triangle. And with interior station. So here we have A, B, C, and D, and one known line. So let's put here a known line. Okay, n prime is equal to 6. S prime is equal to 4. N is equal to 6 and S is equal to 4. Okay, so C is equal to 6 minus 4 plus 1 plus 6 minus 8 plus 3. C is equal to 4. Okay, factor F is equal to D minus C all over D. D is equal to the number of directions observed not including the known side. Okay, so let's count the directions observed. And in our example number 3, it says here all lines are observed in both directions. So one line has 2 directions. Okay, so forward and back. Okay, 2 directions and 2 directions. So our total directions is 10. And the geometric conditions minus 4 minus 10. So, f is equal to 0.60. Our last example, if the distance angles of triangle ABC as shown in the figure is 45 degrees and 71 degrees, compute the value of delta A squared plus the product of delta A and delta B plus delta B squared. Okay, so this is the tabular difference for 1 second error in distance angles. And we will use the logarithm of sine 45 degrees 0 minute 0 seconds. Okay, and the logarithm of sine 45 degrees 0 minute and 1 second. So the answer is negative 0.150 514 99783. Okay, let's add a whole number. So for this example, let's use whole number 10. And the answer is 9.849485,002. So in order to equate to 0.150 we will minus the whole number 10 instead of adding it, so that the values are the same. Okay, so let's try for the 45 degrees 0 minute and 1 second. So the logarithm of sine 45 degrees 0 minute 1 second is negative 0.150 512 892 32. So let's add the whole number 10. The answer is 9.849487,107. In order to have the same values, instead of adding it, we will subtract the whole number 10. Okay, so next step is we will move the decimal point in the 6th place. Okay, so remember that this is the difference per second in the 6th decimal place of logarithm of sine of these distance angles. Okay, so I'll write again 9.849485,002. So let's move the decimal point. So 1, 2, 3, 4, 5, 6 here. So for the 45 degrees 0 minute and 1 second, 9.849487,107. Okay, let's move the decimal point. 1, 2, 3, 4, 5, 6. Okay, so the difference for 1 second is 87.107 minus 85.002. So the answer is 2.105. Next, logarithm of sine 71 degrees 0 minute is negative 0.02432993461. So let's add number 10. 9.975670065. So instead of adding it, let's subtract number 10. So for logarithm of sine 71 degrees 0 minute and 1 second, so the value is negative 0.0243292096.3. So let's add number 10. 9.9756790 minus 10. Okay, let's move the decimal point. 1, 2, 3, 4, 5, 6. The other one. 1, 2, 3, 4, 5, 6. Okay, so for 71 degrees, the difference for 1 second error is 70.790 minus 70.065 is equal to 0.725. Okay, so delta A is equal to 2.105 and delta B is equal to 0.725. Okay, so going back, delta A squared, delta A, delta B plus delta B squared is equal to 2.105 squared plus 2.105 times 0.725 plus 0.725 squared is equal to 6.48. So the value of delta A squared plus delta A, delta B plus delta B squared is 6.48.